Welcome back, Algebrists.
Thank you for the pizza.
You're very welcome for the pizza and ice cream. I hope you enjoyed it. All right. So for today, we are going to start talking about everybody's favorite thing. We've been going through all this stuff like crazy. Now, if we look back at this chapter, it's kind of all around factoring. And it wasn't to begin with. We didn't notice immediately. It's either factoring or graphing. Those are the two ideas that we're seeing. And it makes sense that they go together because we can use those ideas to graph stuff really easily. Okay, if I asked you to sketch something or graph it, are they different? If I said, here's a function, I want you to sketch it, and then tomorrow I give you the same function, I said I want you to graph it, do you get a different picture? So I'll tell you, in my mind, and this is, I'm glad we're talking about it then, when I think of those two things, graphing is a really specific process. I'm going to go through, I'm going to make a table, I'm going to really carefully do everything, I'm going to make it look good. It's going to be as close to possible, or as close as to real as I could. But if I'm just sketching it, I just need the general shape. Like, those are the differences in my mind and the language I'm going to use. So in 3.5, which is what we're starting today, and Deck, just so you know, like, focus on today's lesson. It's not going to change anything about the other one. Like, cool. 3.5, we are going to be talking about the zeros of polynomials. Now, as a kind of reminder, it's been a little while since we've used these. Instead of the word zeros, and you can spell it with OES or just with OS, and I'm sure I'm going to keep referencing that. Jade, can you give me a synonym or another word that means the same as the zeros of a function? So I could ask you to find me the zeros of a polynomial. What else could you ask for? Sure. Solutions. And you can write this more formally if you want, and you don't even need it if you have them. But give me another word, somebody.
Roots.
Roots. And there's one more that, in my mind, is what I associate with graphing. I actually kind of associate zeros. X-intercepts. Now, if we think about what is the whole point of factoring, and I wish that I'd started that with this because it can be hard to answer. Some of you will have very different answers. When I think of what's the point of factoring, 100% is to find these. That's why we factor. We break it down so we can use that zero product idea and figure out where does my graph touch the x-axis. Because it turns out when we model real world situations, that is pretty much always an important point for us. So as we're looking at these, we are going to start making a connection between all of these pieces and what we've been doing. And we'll just jump right in by saying we're going to talk about how do we use roots or zeros, whatever you want to word it, use roots to sketch graphs. Okay, this is our main focus. We're looking at zeros, or the roots and of a polynomial, and now we're going to use them to sketch a graph. Okay, I want to re-stress though, sketching is just that. I don't need to be perfect. I'm not even going to make a table of values. You're going to see some stuff today that's going to feel wonky, but I assure you that it's going to work out and it's going to be nice. So, as we look at this, what I think is the best way to go through, because I can always do a better job of saying here's what we do, like the steps, but not everybody needs it. I'm going to do an example where we'll have the steps working at the same time. Okay, so we're just going to jump right in. How do we use roots to sketch graphs? And then we can say of functions if you want to be real specific. In here, I think that that's implied, but there are graphs that aren't functions that maybe you're just not aware of yet. Okay, so let's just jump right in. And we're going to see in this, I'll work color matching each little part with the step that we're after. So here's what I wanted to do. I just want us to sketch f of x. Now, in the interest of not writing it all and making you guys write a ton of words, I just want to make sure I can see how they word it in here. So your book, when you see things like this, it's going to say sketch the graph of the function by finding the zeros, which is exactly what we're about to do. I just say sketch instead of sketch a graph of the function. Okay, so here we are on our first one. And I've left a little bit of room, just so you know, intentionally so that I can write the steps over here. Like just a little bit of breakdown here. Okay, so let's say that for our first problem, we are going to try to sketch the function f of x equals, and let's just see here. F of x equals, lost my spot, 4x cubed plus 4x squared minus 24x. That's it. That's it. Like, we're just going to try to sketch that. Anybody know what it looks like?
I know it goes through the origin.
It does go through the origin. You're right. I agree with you. Now, right off the bat, I did not put this in first hours, and you may not remember exactly off the top of your head, but all I'm going to do is I'm going to write the steps for this problem right here, okay? It is entirely up to you if you want to write these or not. Okay. Step 1, 2 things. If I write EB, do you know what I'm referring to? Good. I'm going to find end behavior, because we can do that, and factor, f of x, to find, and I don't care which one we use. I'm going to say to find, and I could write interchangeably, roots, zeros, solutions. Which one makes more sense in your head? Solutions? Okay. And I might change this, like in future iterations. With a graph, I think of zeros, but I don't really care which one you write. They're all the same, as long as you know they're all the same thing. Okay, so step 1 is we're going to take this, and we're going to find the end behavior, and we're going to factor. We're going to do that in one step. So first off, anybody know any sweet dance moves? Sweet, you guys do all know some sweet dance moves. You don't have the table right in front of you that we drew in class. Can you show me what the graph of x squared looks like? Can you show me negative x squared? Can you show me y equals x? Can you show me y equals negative x? It's there. Which one of those does that align with? This is our function. It's this. Okay, it's positive leading coefficient in an odd degree. It's worth just jotting down, and I'm just going to make the note here, and we'll have to see it again later. The end behavior, it goes, whoops, wrong way, down to the left, up to the right. Is that the way we had it? Yeah. Okay. There's my end behavior. Now, we need to factor this to find solutions or zeros. When we talk about solutions, it is very specific. We're looking for the solutions when I set this equal to what? 0. And that's why they're called zeros interchangeably. Like, it makes sense. So let's actually try to factor this. And it's weird. Here I am. I don't remember how to factor anything. So that is true. Don't know that it helps here, but I agree with you. Okay. If I want to solve this, 0 is one of them. Like, but let's just make sure we run through. How do I start factoring? Gee, I wish you'd give me something else. See what I did there? There it is. Notice I gave you G and C. That's pretty clever. Okay, we're going to check for GCF. What is the GCF between these three? 4 goes into all three. Anything else? Okay, if we factor out a 4x, I'm going to call in 3 different people here just so you know. First one can volunteer. What's the first thing left in here? X squared or 2x squared? Careful, Keen. Did you take out a 2 or a 4? Okay, because I think you're thinking it 2 still. Okay, if I take out this, it leaves that. Okay, what is left behind here? X. And what about on the last one? 6. Okay, because 4x times negative 6 is negative 24, right? Like, I'm convinced with this. Real quick, just as a reminder, what did we just do? What sort of factoring did we see from here to here? That's a GCF. That's it. Okay, are we done? No. Is this one, does it go any further? Can I factor it more? Just 4x. I don't think so. Like, I could try to call it 2 times 2x, but nothing meaningful changes about it. This is where the one that you noticed and you noticed happens. If I eventually set this equal to 0, it only happens if x is 0. And that's a weird question. When is x 0? And it seems silly to answer when x is 0, but that's the correct answer. Okay. With that in mind, I don't need to do anything else with this. However, is this one done? So run me through the list. There's no more GCF, and I'm only looking at the trinomial right now. I think I can do it here, actually. I'm just going to come sit with you guys. I'm fine with that. If I'm only looking at the trinomial, what? Shortcut. Why shortcut? How do you know there's a shortcut, Jade? If the leading coefficient is 1, it doesn't guarantee that there's a shortcut, but it makes me think that there Could be, right? So if we're looking at, I'm gonna set my comfy chair. If we're looking at this thing, shortcut, I don't remember how that works.
Well, multiply it's
So 1 times -6 is -6. And now I need what?
if it goes
Something that multiplies
You
to
need-
6 but add up to 1.
Well, so almost. Multiplies to -6
Yeah.
and adds up to 1.
Yeah.
And we know the
Negative
numbers.
2 times 3.
-2 and 3.
Mhm.
Now, if this is a 1, and only if this is a 1, how do I use those numbers?
x squared plus
Plus
X plus
minus 2.
-2, and
Yeah.
that was the -2 that you told me, and the other one was a plus what?
3.
X plus 3.
Yeah.
Okay. There's a shortcut happening here, and I'm just going to put it just in case you guys have forgotten. Shortcut. Okay. There's our shortcut. Everybody feel okay so far? Okay. Did we find our zeros yet?
No.
All we found is the what? Factors. Now, I know this is equal to 0, and now we're just going to use the zero product property, whether you actually know it by name or not. If these three things multiply to be 0, then 1 or 2 or 3 of them better be 0. Okay, if you need me to show the work, or if you want me to, let me know, and I can. I'm going to look for my roots, and these are my zeros. If I set this equal to 0, what x do I get?
Negative 2 and 3.
So careful.
0.
Notice, just this.
0.
4x is equal to 0 when x is equal to 0. And that's that weird one. That's always a strange question. What value of x makes this factor right here equal to 0?
2.
2. And that has to be 2. You're saying -2? Because obviously you're looking at it. But what I want you to think about, David, and anybody who's struggling, and if you need to write it, please do. I'm going to erase it in a second. If I have x minus 2 and I set it equal to 0, help me solve that for x, David. And what do you get for x? There you go. Like, that's what's happening. And I'm confident, I know you can do it in your head, but it's easy to get goofed up on stuff. This is the only part that I struggle with. This might be a different color, so sorry if that's the case. Hey, it's not. What value of x makes this one 0?
Negative 3.
-3. Okay. So far, have we done anything crazy?
No.
It feels pretty much just like all the other problems that we've done, right? Okay. That is all step 1, with the exception that we added this end behavior. Okay. For step 2, and I just really want to caution, it's going to look very different if you watch first hour video because it's a different class, and now I'm teaching it 8 hours later, whatever. Okay. Step 2, I'm going to switch to this green color. We are going to do a couple things in this step. We're going to place roots on a number line, and I'm going to let you guys catch up. This is the part where if you're going to get goofed up, it's probably going to happen here. I want you guys to place your roots on a number line. And this part, if we're all good to go, I'll just wait. I'm waiting until I see pencils done moving. We'll appreciate it. Okay, we're going to put these 3 roots on a number line. And check if the function is positive or negative. Positive or negative between roots. Okay, I'm going to make one more comment here, and it's going to be I'm going to talk about all of this stuff, all of this work that we did, because there's a lot of writing, so I hope you don't like zone out like most of the time anyway, but if you are zoning out right now, I want you to make sure you're in right here just for a second, just in case you were zoning out and you didn't hear me say it right. Check it. As we look at this, this function is f of x. Do we all agree?
Yeah.
Yes.
What is this?
F of x.
That's also f of x, right? What is this?
F of x.
These are all versions of f of x. Do we agree with that?
Yeah.
All 3 of them. Like if I wanted to know f of 2, could I plug in a 2 right here, here, and here?
Yeah.
Could I plug in a 2 here or here and here?
Yeah.
And we're going to get the same answers.
Mhm.
That is so important, and people get goofed up on it. I don't know if that's really undoing. It's not, so that's lame. Nope, other way. Okay, those are all f of x. I'm going to just write this comment. This is the factored form. typically, not always, depends, but typically use the factored form. That's the easiest to plug into. Typically, what factored form. Okay, and all that is, and it's going to look ugly for a second, but this is the most factored version. That's what I mean. That is the factored form. Now, the first weird thing about graphing these, and you guys probably won't notice it if I don't say it right now. When I say check the function between the zeros, do I ask you to give me a number?
No, positive or negative.
I only care about positive or negative. I'm never asking for a number. If we wanted a really clear picture, a graph, we would get the number, but we just need a sketch. This is a number. Okay, so I'm going to switch, and we're going to do this. We're going to place those roots on a number line, and we'll just do it right here. And what are the three numbers that go on my number line? In order, hopefully.
-3, 0, and 2.
So -3 is most left or most right?
Most leftist.
Most left on a number line. Okay, -3, 0, and 2. Notice, I put literally zero thought into spacing these out because all I need to be able to do is notice something. Or see that they're there. When I put those three numbers on my number line, how many different regions or intervals did it just cut my numbers into?
3.
You say 3. Oh,
4.
you sure?
5, because
4.
behind -3 and front 2.
4.
Does everybody agree there's a region?
Yeah.
2,
Uh,
3,
4.
there's 4 regions there. Now, we don't have to, if you're shading it, it looks nice, that's fine. We don't have to, I just want to make sure. We all agree there's 4 regions.
Yep.
Okay, this is the weirdest part. I'm going to show the work only on one of them. If you want me to show it on the next one after that, we can. But we're going to place roots on a number line, okay, done. And we're going to check if the function is positive or negative between the roots. Now, there's a little bit more that we could say to be more specific, but the other way that I would word it, and I'm sure how I worded it first hour, is check the value of x in, or the function in each interval. Now, we just identified 4 of them, right? Okay, I'm going to switch color just so it stands out here. Pick something in this last interval, in this region. It can be between -3 and what?
Negative infinity.
Good. I don't want to use negative infinity, but any number will work.
-61.
-61, weird choice, but I'll use it. What's a better choice?
-4.
So I'm going to be honest here. I actually don't mind this choice, and we're going to see why here in a second. -4 is the more natural, reasonable choice, but it doesn't really matter. Okay, I want to remind you, we're in this interval. Now, pay careful attention, and I just, yes or no, did I add any more marks onto my number line yet? No, I'm pointing to where I'm looking, but don't add a mark, especially if you're not going to do the color changing stuff, because I don't think anybody in here does. I have colored pencils if anybody ever wants to. Don't add anything other than the roots here. Okay, and what's the name of the function that we're trying to graph right now? F. So I'm just going to go here. I didn't add it before. I'm going to call this f of x, just so I know what it is I'm talking about. Because eventually, whether it's this class or next, we might have to compare like 3 or 4 functions, and I want to make sure we get that habit built. So I need to tell whether f of this is positive or negative. I don't need the number. Could I conceivably plug it in here and plug in a -61 for each of these? Like, could I plug in a -61 there and there and there?
Yep.
Anybody want to tell me what -61 cubed is?
No.
Me neither. Check it out. I don't even care what the number is. Can you tell me if it's positive or negative?
But negative.
It's negative. Okay. That's really all I care about if we're sketching. I'm going to use this version of it, okay? And we will not write this normally, but I'm going to make sure that just it's super duper clear in our notes. We're going to use the factored form. So I can see it on the board. You may not need this, but use f of x equals, and I'm going to use this one, 4x times x minus 2 times x plus 3. That's the function that I'm going to use, like that version of f is what I'm going to plug into. Now, the reason that we do this is, again, I don't care about the actual number, I just care about the sign of that number. So if we did -61, and I tried to plug in f of
negative 61. And there's so much more writing on this than we'll do normal, just so you're aware. This number, 4 times negative 61. Don't give me the value. I don't care about the value. But can you tell me negative or positive?
Negative.
Everybody agree that that 4 times negative 61 is negative.
Yes.
What about negative 61 minus 2? It's very clearly still negative. And Deck, this is where, like, realistically, when I do these problems, I pick up obnoxious numbers too. Like, when possible, it makes it like super easy to do. What if I plug in a negative 61 here? Negative. Now, if I had used negative 4, does the same thing happen? Would this be a negative times a negative times a negative? Okay, so maybe that would have been easier, but that's okay. All I need to know, and you guys are going to help right now with this, is if I take a negative times a negative, what does it give me?
Positive.
Times a negative.
Negative.
Negative times a negative is positive, and then times 1 more is negative, right? I think that we just determined that my function f is negative between negative infinity and negative 3. Now, when we say a function is negative, it just means that its graph is above or below the x-axis. Below is where the negative values live. Boom. Okay, I'm going to switch colors, and I'm going to do so much less work. And this just so we can, like, differentiate between them nicely. Pick something in this interval, y'all. Somewhere between negative 3 and 0. Negative 2. Now, this is what my work really normally looks like. I have a negative 2, and then if I have this written above, can you tell me if I plug in a negative? 4 times negative 2 is what?
Negative.
Negative. How about negative 2 minus 2?
Negative.
Negative.
Negative? How about negative 2 plus 3?
Positive.
Negative.
Still negative.
Positive.
Positive. Negative 2 plus 3, it's the same thing as 3 minus 2, which is a positive 1. I'm doing the exact same thing that we did here, I'm just not plugging it in. I'm plugging in a negative 2 in these situations. Have I lost anybody? Okay, so what's a negative times a negative? Times a positive?
Positive.
So we just determined that at x equals negative 3, which we already knew was an x-intercept or a root, it crosses and it changes from being negative to positive. Pick something in this interval.
1.
Okay, I think that's a good choice. I'm going to give you guys just a moment. I want you at your desks to do 1, and then we'll try 3 as well. If you think you see a pattern, I wouldn't trust it yet. Honestly, I wouldn't even trust it after we do this example, and we'll see why. But I want you to tell me positive or negative in these spots. I'm going to give you a moment, and we'll meet back up in 3, 2, you know what to do. Nope, didn't pause. Whoops. Right, it doesn't do it over here. What am I talking about?
Well, this is a weird silence or lack of stuff. So here's this one. We get negative. And then again, do not just trust the pattern. Even if it works this time, don't just trust it. I assure you, it will not always work. The pattern you think you see does not really happen, even though this time, does it just alternate?
This can be positive.
Yeah.
It will not always happen. I assure you. Like, I just wanted to make a nice one first. This is not something you should always assume. Okay. Like, for real, don't do it. I'm not just saying it because I'm trying to make you do more work. There's a reason. So, right now, to you guys, does it really seem like we have enough information to graph this function and get a good graph of it? Probably not. I think it's reasonable to say it doesn't really seem like we have enough, right? But I think we do. Step 3. Now that we have all of this info, we're going to sketch the graph. Sketch the graph. Now, when we sketch this, there's going to be something weird that happens. We don't need a y-scale. In fact, I won't put a y-scale if I'm just sketching it. But I do very much have to be able to see my roots. Pick a scale that shows, and I'm not even going to call it roots this time. I'm going to say x-intercepts, since we're talking very specifically about a graph. You can write roots, you could write zeros or solutions. It's all the same. Sketch the graph, and we want to pick a scale that shows the x-intercepts. I'm not going to write it, but I don't even normally bother to write y. Like, I don't pick a y scale. Okay, so let's check it out. I'm going to use a white scale here. What are the 3 values that have to be on my x-axis? So negative 3, 0, and 2. And not my norm, but could I just go -5 to 5, just like this? And I'm just going to label it. Remember, if you don't label it, any tick that is there, like if you're using my graph paper, any tick that you leave, I'm going to assume is 1, unless you label it differently. So notice, I'm not even going to think about my y-axis right now, because I didn't get any signs out of it. All I got out of this was just the value. Don't need any numbers. So out of curiosity, what are you going to type in the calculator? Are you using it as a mirror? Okay. So, check it. To graph this thing, does everybody have a scale? And I just want to make sure that nobody's like behind it. Okay. Cool. If nobody needs more time, what's going to happen at these places? Where is my function?
Gonna go change direction.
It's at the x-axis. It's going to change something, but it's not direction. So I'm just going to plot these points along the x-axis. And I'm going to graph my function. And what color do we start with? Purple? I'm going to graph it in purple. Pink? I don't know. I feel like we've had this discussion a bunch of times. Okay. So I'm going to plot at -3, and I have a hard time seeing mine. There's -3. Here's 0. And here's 2. Those are my 3 zeros. Kian, if you're going to zone out, now's not the time to do it. Give me like 3 more minutes, and then I'll be rude about you sleeping. Okay. I'll warm up to it, too. I'll be real rude. Okay. What do we know the end behavior does? Show me again. What's the end behavior of this graph? I know it goes up to the left and down to the right, which means if it goes up forever, it's never going to cross back over. If I wanted it to turn back around like this, I would have had to have found another what?
Point.
Another point. Be more specific.
Another root.
I would have found another root if it came back down. Those are the only 3 I know it never will. If it has to go up forever, this is the only way they can do it. Do you guys agree? Now, beyond that, whoa, it has to go down forever. What am I talking about? Has to go down forever that way. So like that. Okay. Now, is this below or a negative value right now? Okay. Between -3 and 0, what does it do? It changes to where? It is positive. And the only way to get positive is to pass through the x-axis, right? Now, here's where this is going to be uncomfortable, maybe. Does this graph satisfy that rule? Is this positive above the axis everywhere in here? Okay, and this is the annoying part. Only draw 1. Does this graph also do that?
Yeah, but
Like,
It does, yeah.
they do, though, right? Like, if we never get a y value, I don't know where it is, but I think that I could probably manipulate my scale to no matter what to make it look like this. It might be a weird one. Like, if this is 10, and it's supposed to be at 10, maybe I just say, oh yeah, here's 10, right? Like I can make it fit. Okay, what's it do between 1 and 2? Goes downward. Be more specific, because it's already going downward. It doesn't change direction, but it changes sign. It crosses the axis, right? Okay, so I know that here it crosses. What about on the other side of this root? What's it do once I get past this one? Positive. Now, did I already know that with my end behavior? I already know it goes up forever. This graph, we spent a lot of time talking about it, and I promise that the real problems won't take this long. Is this easier or harder than all the other graphing that we've done, do you think? About the same? So harder's fair. Like, I don't know the right answer, right? It's subjective. I think that if I said, let's graph it like this, or you get me 30 points, this is way easier. Now, you wouldn't naturally pick 30 points, but here's the other big question. How close are we? You think our graph is good? Like, I didn't pick a scale. I'm going to graph it on Desmos, and we're going to check. Believable? I guess we'll see. I don't remember the function, but that's okay. Not by heart. It's not that one either. What was my function?
4x cubed plus 4x squared.
Is that the function that we just graphed?
Yeah.
100% it is. Now, I know it doesn't look like that nice, but I'll just show you what I was talking about because it might not have clicked. If I adjust this and I say, hey, let's step my y's by, if it goes up to 40, let's say it just goes down from -10 or -14 to 40. And I can even stretch out my y's and we can change stuff. If I wanted to step by 10, or 20. Like, I can adjust this and notice how it's changing the scale, right?
Yeah.
So there's 32. There's like, it's changing it. We could adjust the window that we're viewing and make it look more squished like ours. If all we care about is the general characteristics, does this do all the exact same stuff?
Yeah.
100%. Okay. For tonight, I want you guys to do one more for me. One more. You're going to do it in your notes. I'm going to tell you, I am going to have you guys show me this tomorrow. I'm going to hook you up, though. For B, your problem is much nicer. I'm going to call this function g of x this time. We're going to get crazy with it. And I want you to graph the following. I want x minus, I lied, it's going to be x plus 2 cubed and x minus 1 squared. And we may make it x minus 3 also. Okay. For this one, you may have a harder time with the end behavior. Can you guys tell why or how I've hooked you up? Because this problem certainly looks worse. It's factored. That's the hardest part of these problems. If it's factored, and it already is, I'm going to make you guys, I'm going to start because I want to help you, but I'm not going to write all the same annotations. If we have roots, do we have roots? Like, obviously we must.
-2, 1.
So I agree with you, just so you know. But I just really want to zoom in, and this will be the only time I make you do this. Do you agree that this thing, I don't want you to write it, but I just see if you agree. If I wanted to write this all the way, is this just x plus 2 times x plus 2 times x plus 2? And times x minus 1 and x minus 1? Gross. My hand's already tired. And x minus 3. Okay. We got -2, and I've already heard that answer. How many times does -2 show up as a solution? So this is, it's going to feel silly, but I promise there's a reason. -2 showed up thrice, right? All 3 times. Because there's 3 of these factors. And Kian, notice when you solve this, what do you get? There it is. Okay, so as we're looking here, it's tedious and you're going to think it's dumb, but I don't care. I want you to do it. X equals, how many times did it show up?
3.
Write it 3 times. How many times does this 1 show up? So I have a 1 and a 1. And you're only going to plot the point once because you can't plot the same point over and over, but there's a reason we're doing this. And the last root? 3. I want you guys to finish and sketch this graph this evening. Realistically, you come close to finishing now, but by tomorrow, I'm going to count this as an assignment. I'm going to check your notes at the start of class. Cool. I'm going to write it on the board because I'm going to forget if I don't do it. Cool.